Hi everyone, in this video presentation we are going to look at constructing triangles, a continuation in constructions on locus of points. Okay, so we are going to look at how to construct a triangle, and an example is as below. Okay, and there is the example, and it reads: construct triangle ABC in which AB is 5 centimeters, BC 8 centimeters, and AC 4 centimeters. And then we have B, which reads: measure and write down the size of angle ABC. So we start with the first one, which says construct triangle ABC in which AB is 8 centimeters. So I'm going to construct AB, the side AB, which is equal to 5 centimeters. Okay, so there is the length, 5 centimeters. We just make it somewhere in the middle here. Okay, AB 5 centimeters. AB 5 centimeters. Okay, here it is. We even record to say A, B. Even write 5 centimeters. And then we are told that BC is equal to 8 centimeters and AC 4 centimeters. Okay, so when we look at this type of a triangle, the construction of this triangle, we have seen that it does not involve any angle in the process, because all we have are just sides A, B, BC, and AC, just like that. Okay, so now how do we work out this type of a triangle? So to finalize this, you need the help of a protractor. You need the help of, not really a protractor, but a compass. You need a compass there, and also a ruler. Okay, so you need these instruments in order for you to work out the rest of the parts. Okay, so like for BC, which they have told us it's 8 centimeters, you have to construct it. You have to open your compass to a radius 8 centimeters using this ruler. You do something like this. You go on your ruler there, you insert there, and then you open your radius to 8 centimeters. Okay, something like that. I'm sure you can see that this is 8 centimeters. Okay, that is exactly 8 centimeters. This radius 8 centimeters. So what you do with this radius, you have to go and insert, since what the length we want to find is BC, meaning from B here up to somewhere this side. Okay, because C, we have to make sure that it is somewhere this side. If we can even let it be down here, but I think we have much space here, so I'll opt to make sure that my point C is somewhere here. So I'm going to fix my compass pointer at that point, at that end there. I insert like that. Then I construct an arc. Okay, so what I'm doing here, I'm constructing an arc that is equal to 8 centimeters from point B. That is what I'm doing. So I have to do something like this. Okay, you construct an arc, and this arc represents the locus of points which are 8 centimeters from point B. Okay, so the distance from each one of these points to B is equal to 8 centimeters. Okay, so we temporarily do that. Then we construct another arc that is equal to 4 centimeters. Okay, we've been told that AC is equal to 4 centimeters. Okay, so AC should be equal to 4 centimeters. So first of all, anyway, let me just increase my radius a little bit. Let me make sure that, okay, at least it is somewhere there. Your arc must be long enough so that at least by the time you are constructing the other one, it does not conflict in any way, because the arcs must intersect at some point. So the next thing that I'm going to do now, I have to open my compass, this one, to a radius of 4 centimeters so that I construct another arc from A. So I pick my ruler, okay, then I fix it at the starting point of the centimeters, then I reduce this. Initially it is 8, I just reduce this to 4 centimeters, something like this. Okay, I'm sure you can see that this is exactly 4 centimeters. So I'm going now to construct another arc that is equal to 4 centimeters from A. Okay, so I have to fix my compass pointer there. Then I construct that particular arc like this. Okay, I'm sure we can see where the two arcs have met. This arc, the whole lot of this arc and this arc here, they have met at that particular point there. Okay, they have met at that point. So they don't look quite clear, so allow me to just protrude that one a little bit to 8 centimeters so that you see clearly. Okay, so this was initially 8 centimeters, so we can do something like that so that it looks perfectly clear. So you see, that's the importance of drawing your arc that is at least long enough so that it meets up with the other arc after constructing it. So we can see the locus of points 4 centimeters from A is represented by this arc that I've drawn here. Then 8 centimeters from B is represented by this. So the point where these two arcs are meeting here, that is where point C is. Okay? That is where point C is. So I'm simply going to put C here, acknowledging the fact that this is where the point C is, and then I just complete this. So I'm going to draw a straight line. Okay, like that. I draw another one like that. By so doing, I've completed constructing the triangle I was told to construct, triangle ABC, where AB is 5 centimeters as you can see, then BC is 8 centimeters, and when we measure from here, you will confirm and prove with me that this is exactly 8 centimeters. I'm sure you can see that. From here up to that vertex there, this is 8 centimeters. You even write to say, okay, this is 8 centimeters. Then the other one, AC. We are told it is 4 centimeters, and for sure, when you measure, you discover that this is exactly 4 centimeters. As you can see, from here to there, it's exactly 4 centimeters. So you even write to say AC is 4 centimeters. That's how you construct a triangle like that. Now, we've been told to measure and write down the size of angle ABC. okay, angle ABC. So how do we measure this particular angle ABC? The letter in the middle is B, so meaning that the angle that will be of us to measure is actually this one here. Okay, so to measure this angle, you need the help of a protractor. Okay, remember how to measure angles using a protractor. Okay, so you need the protractor, ensuring that the center point, this one here, the center point, which is this one, is placed at the vertex, which is there, and this line here, okay, is exactly on top of this other line like this. Okay, you do something like that. Alright, so you now begin measuring the angle. So now your starting point is this one. So this angle will be measured in a clockwise direction. Okay, so 0, 10, 20, this is the 20th degree, 21, 22, 23, and we can see that it is in the mid here. So you can say 23.5. Okay, half of that 23.5, of which if we want we can round it off up to 24, but this is exactly midway there, so it's appropriate and important obviously to just say this is the 23.5 degrees. So you can choose to write either here or elsewhere. You say okay, angle ABC is equal to 23.5 degrees. Okay, for me that is what it's giving me. Those of you that may wish to write 24 degrees, you can still be marked wrong. You can still be marked correct. Okay, others may wish to write 23 degrees. I think you can still get that one correct. So basically this is how you construct this type of a triangle. Okay, so we have another example here, another type of a situation in which we can be given a triangle, and it reads, construct triangle MNL in which LM is equal to MN is equal to LN, which is 8 centimeters. Okay, so we have to construct that one. Then later measure and write down the size of angle LMN. Okay, so how do you work out this type of a situation? Okay, so what you do, since all the three sides are equal, so that should do, click to your mind to say the type of a triangle you're constructing is equilateral triangle. Okay, it's an equilateral type of a triangle. Alright, now what is an equilateral triangle? It's a triangle where all the three sides are equal, even all the angles are also equal. The interior angles, they are also equal. Each one is equal to, in fact, 60 degrees, as we are going to prove here, because that's the way it is. Okay, so what we are going to do is we are going to get our compass. We're going to get our compass, which is this one, and open it to a radius that is 8 centimeters. So you get your ruler, you place it there. Okay, then you would have drilled some bit of a hole on your ruler, and then you open the radius to 8 centimeters. Okay, I think that is equal to 8 centimeters, as you can see. This is 8 centimeters, starting from the starting point here. I'm sure you can agree with me that this is 8 centimeters. This is 8 centimeters. If you start from the starting point, let me just confirm. extrude it a little bit. Okay, I think something like that. So this is 8 centimeters. Okay, so what do I do with this? So first and foremost, so what you can do, you can actually choose to fix your compass. You can, there are two ways you can do this. It's either first of all you draw a line that is equal to 8 centimeters, or you do it directly like the way I'm doing it. So like for me, if I choose to go direct, I'm going to fix my compass pointer anywhere here. Okay, I fix it there. Then I construct an arc. Okay, I construct an arc like this. Okay, then I can also, I think, go on top like this. You construct another arc. So then, not forgetting where you started from. Then I fix my compass pointer here. Then I do the same thing here. Okay, so the distance from here up to there is 8 centimeters. Then I also cut there. Okay, so then I should have not forgotten where I've inserted this. Okay, so I had drilled, I had inserted this line here as well as there. So I'm going to draw a straight line there. So I'm going to draw a line that will pass through that point as well as that point like this. Okay, so that is equal to 8 centimeters. Then also from here, okay, that side, as well as this side. Okay, so M and L. So if you want, you can say M and L like that. Each one of these is equal to 8 centimeters. So there is 8 centimeters. Even here is also 8 centimeters. Equally, this side is equal to 8 centimeters. Even if you measure, that's what you find. So from here to there is 8 centimeters. And then this side, from here up to there is also 8 centimeters. And then from here up to there, from here up to here, it's also 8 centimeters. Okay, as you can see, that is 8 centimeters each. Then the next question is, measure and write down the size of angle LMN. Angle LMN, so meaning this angle here. So, how to measure? Remember, the center point, which is this one, must be placed at the vertex there. Something like this. Okay, something like this. So the center point is there, and the line, this part of the protractor, is on top of this line that is drawn. So now the angle should be measured in an anti-clockwise way, because the starting point is there: 0, 10, 20, 30, 40, 50, 60. Okay, so you can see that is 60 degrees. You even show it here. It's 60 degrees. That's the size of angle LM. If you want, you can even show it outside. LM. MN is equal to 60 degrees. If you remember earlier, I mentioned to say if your triangle is equilateral of n length, all the interior angles are equal. Okay, so that's why I shouldn't be surprised that this is 60 degrees. Even in any other angle here, if we want, we can even measure the other ones here. Okay, from the vertex there. Okay, we can see from 0, 10, 20, 30, 40, 50, 60 degrees. Even the other one. Okay. Even the other one is also 60 degrees, as we can see, 0, 10, 20, 30, 40, 50, 60 degrees. So that's it. So when you're given to construct an equilateral triangle where all the three sides are equal, this is what you can basically do, boys and girls. Okay, so we move on. Okay, so sometimes you can have an example like this one, which says construct triangle ABC, in which AB is 7 centimeters, BAC 100 centimeters, BAC 100 degrees, and angle ABC 35 degrees. So the last two are angles. Okay, then out of that they have asked us to measure and write down the length of BC. So you can see this is a situation where you're given only one side and the rest are angles. Okay, you can see there's only one side, AB 7 centimeters, then the rest are angles. Okay, so we have BAC 100 degrees, ABC 35 degrees. So if you happen to be, or rather face such kind of a situation in an exam, how can you answer it? Very simple. So what you do first, you measure the length AB, which is 7 centimeters. So you get your ruler. Okay, so I construct my 7 centimeters length somewhere here. Okay, I'm sure we can see that is exactly equal to 7 centimeters. Okay, so that is our AB. So write A, B, and we indicate that this is 7 centimeters. Then BAC 100 degrees, that angle. Okay, this is another denotation for angle. So when you see this, it represents an angle. It's not different from someone who would have written it in a different way. Okay, would have used the word to indicate that that is an angle. Both people, rather individuals, are not different at all. So since we have to construct angle BAC, meaning the angle at A, which is 100 degrees, okay? 100 degrees. So we get our protractor, because this is one angle that can be constructed with the aid of a protractor. So you get your protractor, ensuring that the center point here is at the end there. Okay, something like this. Then you measure your 100 degrees. Okay, so now we are going to start from here. You can't start from here because we don't have a line here. The line is here. This line is lying on top of that one, so that's why you have to start from here. There is no line, so you can't start from here. So you start 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 here, 100. So this is the 100 that we are going to follow because we are moving in an anti-clockwise direction. This one, we started from 0. So if you are such an individual who can easily be misled, you just look around where the 100 is, and by mistake you happen to see this one. This 100 is incorrect if you mean this angle this side, okay? This 100 is a situation where you are starting from here. So the correct 100 degrees is this one, where you started from 0 like that. So where there is on top of 80 here, that's where you are going to put a dot somewhere there. Okay. Then you get your ruler. Okay. You get your ruler. And draw a straight line. You draw a straight line. Something like this. Remember, we've not been given length. We've noticed the length has not been specified. So you can draw at least something that is reasonably long enough so that it helps to deal with the other one. Okay. So this is 100 degrees. Okay. The angle BAC. Okay. BA, so we have C somewhere, anywhere along this. Okay, it can be here, anywhere. So what will help us know exactly where that angle is? It's this other angle which they said angle ABC. Okay, ABC means the angle at B. AB, so C. So we just construct a 35-degree angle here, then we draw a line that is going to meet up with that one there. Okay, so how do you draw the 35 degrees? You get your protractor. Then ensuring that the center point is there. Okay. The center point is here. And then you draw 35 degrees. 0, 10, 20, 30, 35 is somewhere here. There. So you put a dot like that. Then you get your ruler. Then you draw a line. That is passing through this. Okay, so this angle is 35 degrees. Okay, so meaning the point C is exactly here. Okay, that is where the point C is. So this is how you construct a triangle when you've only been given one side and the rest are angles. Now out of this, you deliberately be asked to measure and write the length of BC. Okay, BC meaning this length here. From here up to somewhere there. So this is 9.8. Okay, this is exactly 9.8 meters. For me, that's what I'm finding. 9.8 centimeters. If you record somewhere if you wish, okay, you say BC is 9.8 centimeters. So this is how you construct a triangle when you have been given such kind of a situation. Okay, so having looked at those three examples, this is your exercise. I'll need you to try it out. Thank you. Enjoy it.